So, now let us discuss one problem, one example problem. In a 4-bar chain, I will read the problem now. So, in a 4-bar chain ABCD, AD is fixed and is 120 mm long. The crank A is 30 mm long and rotates at 100 rpm clockwise, right. So, while the link CD, which is equal to 60 mm, oscillates about D. So, BC and AD are of equal length. Find the angular velocities of link CD when the angle BAD, which is equal to 60 degree, right. So, this is the problem. So, it is a 4-bar mechanism. They given in the problem. It is a 4-bar mechanism. So, 4 bars are there. So, AD is fixed, right. So, first so draw the configuration diagram. This is step 1, right. So, first we have to draw the configuration diagram according to the given data, right. So, configuration diagram, which is equal to see how. So, take suitable scale and draw this configuration diagram. First fix the point A and draw the horizontal line AD, which is equal to 120 mm given in the problem, AD which is equal to 120 mm long, right. So, it is fixed, they said AD is fixed, then we have to hatch this line AD, which is a fixed line. So, this hatching, which means it is a fixed line, okay, right. Then next, the crank AB is 30 mm long. So, from this point we have to draw a 30 mm line, and extra data is also given when the angle BAD, which is equal to 60 degree, right. So, take A as a center point, and from this point you have to draw a line with 60 degree angle, inclined line, and take a compass and measure 30 mm and take A as a center point and cut the arc, and you got point B, which is 30 mm and 60 degree inclined line, right. So, B point we got. Now, we have to find C point, right. So, read the problem. While CD is 60 mm, right, and about D from D 60 mm, and BC and AD are equal length, okay. Now, take a compass and measure 60 mm and take D as a center point. See, they given CD, which is equal to 60 mm, oscillates about D, right. So, take 60 mm in the compass and take D as a center point and cut the arc, right. Still we have to find point C. So, see, BC and AD are equal length. So, BC, which is equal to AD. So, the dimensions of AD we know that 120 mm, and now take a compass and measure 120 mm and take B as a center point and cut the arc, right, the cutting point, which is called point C, right, and mention the dimensions 120, 60, 120 mm and 30 mm, and one more data is also given. The crank AB is 30 mm long and rotates at 100 rpm clockwise. So, this is clockwise direction, right. So, we have to mention 100 rpm clockwise, right, direction, which is a clockwise direction, right. So, data N is given, NAB, which is equal to 100 rpm. So, we have to calculate omega, angular velocity of the link AB. We have to calculate. What is the formula? 2 pi n divided by 60. With the help of this formula, we can calculate omega AB, angular velocity of the link AB, right. Now, we have to move on. Step 2, calculate the velocity of input link using formula. Already we know that what is the formula for input link? Here input link, which is equal to AB. So, velocity of B with respect to A, which is equal to angular velocity of AB into the length of the link AB, right. We know that omega AB we calculated from this formula 2 pi n divided by 60, right. So, the length of the link AB, which is equal to 30 mm, we know that. Now, the speed of the input link NB, which is equal to 100 mm, with the help of this formula we calculated 10.47 radian per 7, which is equal to the angular velocity of link AB. So, this is the formula already we discussed, BA, which is equal to omega BA into length of the link AB. So, omega we have to substitute this 10.47 into the length of the link AB 30 mm, we have to substitute the value in meter. So, 0.0 0.30. So what is the velocity of B with respect to A? 0.3141 meter per second. So that velocity which is perpendicular to the link AB, right? This is the velocity of link B with respect to A should be perpendicular or must be perpendicular to the line joining of these 2 points. Already we discussed in our previous video, right? So see, direction which is clockwise, that's why we have to draw the perpendicular line towards clockwise direction, right? So next, third, so this is configuration diagram, already we discussed, and now draw the velocity diagram. First we have to draw the velocity diagram. So for that we have to fix the point, fixed point which is fixed point O. So here the fixed point, not O. See the link A and D, there is no relative motion. So this is a fixed point. So we have to mention A comma D. It's a fixed point. There is no motion. So velocity at this point which is 0, right? So velocity of A is 0, right? So we have to find, we already calculated velocity of B with respect to A. So velocity of B with respect to A which is perpendicular to the corresponding link, already we discussed. This is velocity of B with respect to A, already we calculated. How much? Previous slide value which is equal to 0.3141 meter per second. This is the velocity of B with respect to A value, right? So first fix the point AD, right? And we have to draw the perpendicular line for this AB, right? So we have to draw a perpendicular line which is perpendicular. We have to draw the line with a magnitude of 0.3141 meter per second, which is perpendicular to the link AB, right? The direction which is clockwise direction already they given, right? So take suitable scale, right? 1 centimeter which is equal to 0.1 meter per second, right? For example, 1 centimeter which is equal to 0.1 meter per second. So for this 0.3, which means 3 centimeter, right? So 3 centimeter we have to draw a line which is perpendicular to the link AB, right? So for 3 centimeters we have to draw the line. So this point which is equal to B, right? So this is the direction velocity of B with respect to A, right? First one over. Second one, BC, we have to find the velocity of C with respect to B. So that is perpendicular to the link BC, right? We don't know magnitude. See, what is the formula for this? Velocity of C with respect to B which is equal to angular velocity of BC into the length of the link BC. The length of the link BC is known value, but this is unknown value. So we can't calculate velocity of C with respect to B, but we know that the direction velocity of C with respect to B which is perpendicular to the length of the link, but the direction we don't know. Either maybe this side or that side, that we don't know. So but the line which is perpendicular to the link BC. So from point B we have to draw a line which is perpendicular to this link BC, right? So this is the line which is perpendicular to the link BC. Now move on to the last link CD, right? Now we have to calculate the velocity of C with respect to D. Velocity of C with respect to D which is equal to angular velocity of CD into the length of the link CD. The length of the link we know that, but angular velocity of CD we don't know. So it's very difficult. We can't calculate this velocity of CD, but we know that the direction of velocity of C with respect to D which is perpendicular to the link, velocity of C with respect to D which is perpendicular to the link, either maybe left hand side or right hand side, that we don't know. So from D point we have to draw a line which is perpendicular to the velocity of, the line CD, right? Now draw the line which is perpendicular to CD through D. So this is the cutting point we got. So this is called as C, right? So draw the arrow mark velocity of C with respect to B. Similarly for this velocity of C with respect to D, right? So now we know that velocity of B with respect to A now we have to measure, now we have to calculate velocity of CB and velocity of CD. So, how to calculate velocity of CB? Velocity of CB which is equal to measure this vector BC, right, vector BC we have to measure and multiply with this 0.1 meter per second, then this centimeter is converted into meter per second, right. Similarly, the velocity of CD also measure this vector CD and multiply that value into 0.1 meter per second, then that value is converted into 0.1 meter per second. So, this is in meter per second and this is in meter per second. Let us see the answer. Now, take suitable scale 1 centimeter equal to 0.1 meter per second, and since the link AD is fixed, then the velocity of point A and D is 0. So, this is the fixed point AD, right. See here velocity of BA which is equal to VB. So, velocity of BA which is equal to VB, already we know that, which is equal to 0.3141. So, this is the diagram of, this is the velocity diagram. See, this is fixed point and we have to draw AD, vector AD which is perpendicular to the link AB, and once we got this point B, then we have to calculate the velocity of C with respect to B. We don't know magnitude, but we know the direction which is perpendicular to the BC. Then draw a line which is perpendicular to BC, and this is the line BC, right. And similarly for CD, we have to draw a line which is perpendicular to this line CD from D, right. So, cutting point which is equal to C. So, measure this vector CD and the vector CD and the vector CB, right, and convert to the meter per second squared. See, the angular velocity of link CD which is equal to 0.2387. This is after calculating, after multiplying the scale, right. So, we know that already velocity of CD which is equal to angular velocity of CD into the length of the link CD, right. Now, this is now we know that this we have to calculate the angular velocity of CD. So, the velocity of CD divided by CD, right. So, velocity of CD which is equal to 0.2387 divided by CD in meter, then final value which is equal to 4 radian per second. We will discuss another example problem. I will read the problem now. A 4-bar mechanism has the following length in mm. The input A0A is 25 mm, coupler AB is 70 mm, output B0B is 45, and frame A0 B0. Frame A0 B0, it's a fixed because it's a frame, right. So, frame A0 B0 is 60 and coupler point A is above and the B is below the horizontal frame A0 B0 respectively. When the input link is in an angular position of 105 degree counterclockwise from the frame link, draw the 4-bar mechanism. So, it is a 4-bar mechanism given, right. So, if the input link rotates with a constant angular velocity of 2.5 radian per second, if the input link rotates, so which is called as omega of input link, which is equal to 2.5 radian per second. Determine the linear velocity of VB. So, velocity of B we have to calculate, right. So, velocity of B of the output link. So, velocity of B which means output link velocity and the angular velocity of the output link. So, velocity B we have to calculate and omega B we have to calculate. Okay. So, now first according to the steps, first we have to draw the configuration diagram, right. So, take suitable scale 1 centimeter which is equal to 20 mm, say for example, right. So, take any suitable scale whatever you want and draw the configuration diagram. First A0 B0 we have to draw 60 mm. So, 60 we have to draw the line. See here I am going to draw 60 mm. This is A0 and this is B0, right, 60 mm. Then draw a 105 degree inclined line, 105 degree inclined line. So, this is 105 degree. Now, AB which is a coupler. So, A0 A which is a input link, right, and A is above and B is below. So A naught A, which is equal to 25, right? It's an input link. So take a compass and measure 25 mm and take A naught as a center point and cut the arc. So this is actually A, right? Now A, now B. So what is the length of AB? See here, the A is above and B is below the horizontal frame. So A is above, this is A, then the B, it should be in bottom of A naught B naught, right? So somewhere bottom of this A naught B naught, right? It's a fixed frame. So it's a fixed frame. And now concentrate on this 70 mm. So take a compass and measure 70 mm and A as a center point and cut the arc, right? So here somewhere B is there, right? So now B naught B, which is equal to 45. Now B naught, we know that. So take a compass and measure 45 mm and take this point as a center point and cut the arc. So this is point B, right? So join B naught B and AB, right? So this is the configuration diagram. So let us see the configuration diagram, right? So this is a fixed A naught B naught is a fixed frame, and A naught A, which is equal to 25, and it's a clockwise direction, and it makes 105 degree inclined line, and this is 70 mm and this is 45 mm, right? After configuration diagram, we have to calculate the input link, the velocity of input link, right? So here the velocity of input link V A naught A, right, which is equal to input link angular velocity of A naught A into the length of A naught, right? The velocity of A naught, which is equal to 0.0625, okay? So the velocity of A naught, which is equal to angular velocity of A naught into the length of the link A naught. So substitute all the values in this and you got 0.0625 meter per second, right? So now take a scale, suitable scale, 1 centimeter equal to 0.05 meter per second, right? And now we have to fix the point A naught B naught, right? First we have to fix the point A naught B naught. So here I am going to draw. So this is the point A naught comma B naught. So this is a fixed point, right? So velocity which is equal to 0, right? So first we have to draw the perpendicular line, the magnitude which is equal to 0.0625 meter, and which is perpendicular to the configuration diagram link A naught A, right? See, so this is the configuration diagram. See here, this is a fixed link. So now we are going to draw a line which is perpendicular to this A naught A, because the velocity of A, which is perpendicular to the line joining of A naught, right? So here the direction which is equal to clockwise, so the direction which is right hand side. So from this point we have to draw a perpendicular line, the length which is equal to 1 centimeter equal to 0.05. So for this, how much? Calculate and draw this. So this is point A, right? So now we have to draw the line perpendicular to this A B, because now we are going to find out the velocity of B. The velocity of B, which is perpendicular to the line AB, either maybe this side or this side. This is velocity of B with respect to A, velocity of B with respect to A, right? So from A we have to draw a line. See here, from A we have to draw a perpendicular line. Okay, so somewhere C is there. Now draw a velocity of B naught B line. So now consider B naught B, and the velocity of B with respect to B naught, which is perpendicular to the link B naught. Either may be velocity of B with respect to B naught in this direction or in this direction, velocity of B naught. So we have to draw a line which is perpendicular to this B naught, right? So from fixed point B naught, and this is the cutting point called B, and this is the velocity of A with respect to A naught, and this is the velocity of B with respect to A point, and this is the velocity of B with respect to B naught, right? So the arrow mark towards B, that is why this is velocity of B. So, here the arrow mark towards A, that is why the velocity of A with respect to B naught, right. So, this is the way we have to draw the velocity diagram, and directly we are going to measure the velocity of B A, measure this vector A B, which is equal to that measurement into this scale, right. So, then that value is converted into meter per second. So, which is equal to velocity of B A, right. So, similarly, see velocity of B naught, which is equal to this value, and we know that velocity of B naught, which is equal to angular velocity of B naught into the length of the link B naught. The length of the link we know that, this is we do not know, we have to find this. This is we measured. So, omega B naught, which is equal to velocity of B naught divided by B naught. Okay. So, this is 0.4 radian per second.